Hello, everyone, and welcome to another edition of the Light Reading Podcast. My name is Phil Harvey. I'm an editor here at Light Reading, and I have a guest today. My guest today is Matt Brice. He is at Prysmian, the fiber provider, manufacturer. Matt, thanks for joining us.
Yeah, thank you, Phil. Good morning.
It's been good to talk to you again. Now, you're based in the U.S., and Prysmian is not. So I think a great place to start is give us an idea of what Prysmian's operations look like in the U.S. I think people might be surprised at just how established you all are, and also what capacity you're capable of.
Sure, Phil. Thank you. And especially in today's market, things are happening at a rapid pace. It seems there's a press release with new expansions within our industry almost daily, or acquisitions, right? So just within the last few years, Prysmian has invested heavily in the North American market, to the tune of $30 million in Jackson, Tennessee, to convert an old copper plant over to being able to produce fiber. And then another $50 million multi-year agreement in our Claremont facility in North Carolina. And there's still more investment to come. We have another plant in Lexington, South Carolina that produces a lot of our ribbon products. And that is especially of note in today's marketplace because of everything happening with data centers and, high bandwidth needs.
Yeah. Yeah, I definitely wanted to get into that because that's definitely a market, I guess, pressure point at the moment as we're seeing the massive expansion of AI related data centers. So yeah, it's a pretty broad operation, growing all the time. Yeah, I think there's some online, or there's at least was it on YouTube or somewhere. You guys have a nice video, kind of giving a tour of the North Carolina plant, I believe.
Yes.
Really, really interesting, to I think walk people through the advantage that you have in both making you make your own fiber, but you also make the cabling part as well. What kind of advantage does that sort of give when you're talking to customers who are in the market for fiber?
Sure, Phil. Well, being that vertically integrated in North America is somewhat rare. There are only three manufacturers of fiber optic cable in the United States that can go all the way back to the optical preform, which is the large piece of glass that then gets drawn down into the fiber, that gets coated and then placed into a cable. So from a made right here in North America perspective, we'll be able to offer products that are BABA compliant for the current BEAD initiative.
Okay. Yeah. Yeah. I was going to ask you about BEAD because that's obviously a market catalyst that we're seeing along with the AI sort of build out. Um, I guess we could start with the fiber itself. So I mean, in the BEAD build out, what are the challenges there? Is it I know that there seem to be political changes afoot in how BEAD is administered, and kind of the different and this different administrations take on broadband expansion in different ways. I'd be interested to get you to sort of give us a bit of insight as to how that's affecting fiber output, but also it'd be interesting to know just how Prysmian is preparing for what what seems to be a ramping and incredibly steady build out of fiber over the next few years. Now that a lot of states have identified, an aching need for connectivity in parts, and whether or not BEAD exists, it seems like they've gotten the message to address that in order to improve their own economies.
Yeah, that's a great question, Phil. And at this point, stage in history in North America, there is a dichotomy in the need for optical fiber. If we're going to bring strands of glass to rural America, those cables require much fewer fibers than it would to connect to data centers. So, and to kind of answer that question, I'd like to step back a little further in history. Is that we've had these peaks and valleys of fiber demand over the course of time, and there were numerous industry drivers, whether it was, previously 5G. Before that, we had all of the state networks with the BTOP program, and then, of course, in the early 2000s, the .com era.
Right.
So we have that kind of two business segments that are at odds with one another, because on one hand, the data centers are driving cable manufacturers like us to push the limits on fiber count and cable size. For those who are on listen only mode, I'm holding up a sample of a cable that's 6,912 fibers
Mm.
that is commonly used to connect data centers, even before we talk about the AI sphere.
Hmm.
And then rural America, kind of on the opposite side of that trend, is trying to figure out how few fibers they can get to accomplish their goals in the same thing. So to kind of button that up, it used to be for the last 4 to 5 years, the average fiber count was somewhere around 50 fibers within a cable.
Okay.
Now we're seeing demand 4 to 5 times that, which is going to then put a strain on the overall glass availability. So whatever the catalyst is for the shortage of fiber cable at the end of the day, that optical fiber is becoming a choke point due to the higher strand counts that are being deployed today.
Yeah, that must make for an exceedingly difficult job in terms of forecasting demand from a manufacturing point of view, because you've got these two opposite ways of thinking about fiber demand. There's um, small cable, few fibers, and then there's giant cable, lots of lots of
Yes,
fibers.
yes. Yeah, and the giant cables, lots of fibers, like I said, they're kind of pushing the limits of what's possible, really, and utilizing a lot of the newer technologies that we have today with bend and sensitive fibers and things like that.
Yeah, for the rural markets and for the bead build out, it's a an entirely different thing. A lot of places haven't had fiber before, or they've got very old infrastructure in the ground. So for those, it's more about just getting raw connectivity. So I would imagine those are kind of legacy fiber products do quite nicely in those areas, and
Yes.
there's maybe a priority on distance over um, the capacity that they can carry.
That's a good point, Phil. Although I will say, there have been newer cable designs that Prysmian has brought to market as well to better serve the rural space, because again, it's very costly to reach those areas. So if we can create a design that's going to allow even the smallest measurable increase in speed to market,
Yeah.
that pays huge dividends in how those projects are able to spin off. So yes, we do have a couple of new products in our portfolio that are more flat cables that are self-supporting, that were really well suited for aerial deployments in rural markets.
Does having this presence in the U.S., the ability to be able to do both, address both markets in country, um, how does that sort of position you guys in terms of a market advantage? When it comes to what I would say the economic uncertainty of our current trade environment. Because it's like there's obviously a lot of trade deals being negotiated, renegotiated. There's tariff threats and realities going back and forth, and you guys are sitting in the middle of it, being both a multinational, global company, but also realizing that the a lot of the money in the market is kind of fixated on North America at the moment.
Yeah, Phil. So it is interesting to say the least, with everything going on. And you mentioned the tariff word. Copper is not something that's under my purview per se, but it's a large part of Prysmian as a whole.
Mhm.
Um, Obviously, copper's now at a record price, and that part of the business is keeping a very close eye on it. But some of the things that may not be talked about from a fiber perspective is yes, there are certain components of fiber cables that are just simply not made here today, can't be sourced.
Right.
So certain types of cable may be excluded from the BABA requirements. But as Prysmian's strength is that we do have fiber plants elsewhere around the world in Brazil, in Spain, in many other areas that we can pull from to help meet demand globally and here in North America. So that gives us certainly some leverage to prioritize those projects that need to be made right here versus
Mhm.
those that are up to the customer's discretion.
Okay. Let's talk about a little bit about the kind of the technical differences in how fiber is evolving, and then we can, you can kind of apply or talk about how this applies to the two sort of large markets your uh, that are being targeted for telco purposes, service provider I say telco service provider and cloud, I guess, purposes. But I'm very curious about hollow core fiber and what the main characteristics are compared to traditional fiber. One of them sounds obvious, but why that
Yeah.
is a catalyst for next generation networks? Kind of what characteristics does it sort of add to the network that weren't there before?
Yeah, Phil. So there's a couple things going on, right, still in the background to help develop for hollow core and of course quantum computing, which we're just now getting into. There have been several hollow core fiber designs over the years, similar to silica core fibers. There was that progression of how far can we get a signal to travel before and where is that distance going to be an acceptable level of attenuation. So we've gotten there with hollow core fiber. It can transmit over long distances at lower latency, which is everything you want, right? But now begins the industrialization process to make that uh, nodeless nested anti-resonant fiber much more broadly available in the market. So there's two major players in that space today, and Prysmian has made major inroads with relativity networks
Relativity. Okay.
in a partnership to help develop that hollow core fiber more, industrialize it, get it into cables so then it can be used. But in today's market, it just may not be ready enough to be widely deployed because what we saw in the latter half of 2024 was this explosion in the market, this need to join all these data center facilities across different markets, across much longer distances. It wasn't just from Ashburn to Alexandria. It was now Chicago to LA, Denver, interconnected cities like that. And for fiber counts that were much greater than what had been deployed in those routes before. The interesting thing is, those routes already had a lot of duct in place.
Mhm.
So the question we heard most often, more than ever, was how many fibers can I get in X amount of space? It wasn't, I need X amount of fibers to get, it's how much could they get to go in that existing duct space?
Mhm.
So to come back around to the technology portion of the question, to get cables that can be that dense um, with single mode optical fiber, the fibers must be bend insensitive. And, all the major manufacturers are doing this. Say a leg up that Prysmian has across the board with bend insensitivity, and that's a hard word to say.
Yeah, it is.
Bend, bend insensitivity is our Ben Bright fibers were first to market with all of the ITU specs that have been rolled out. And part of our deposition process in making that fiber, kind of getting super technical for just a second,
Mhm.
is we're putting thousands of layers in the cladding that then really truly safeguard against micro bends, which become much more prevalent in dense fiber cables because you have them just crammed in such a small space.
Right.
Um, so that's been a very important step in unlocking the ability to construct these cables and make them with low attenuation that can meet the needs of today's demand for AI. Hopefully then still leaving some room at the table for hollow core and some of the new technologies to play a role.
Okay, so hollow core is definitely it's something that's out into the future, and then but you guys are preparing now to make sure it's readily available when the time comes. At the moment, how what are the risks? When you start, you kind of touched on it a little bit, but when you start cramming so many fiber into a single duct or cable packaging, um, what can happen, and how do you kind of avoid that, or in terms of the data transmission?
Yeah, first the the micro bending aspect, just to go a little deeper into that, is when you have a micro bend in a fiber, it's very hard to detect on an OTDR trace. You really can't see it. But cumulatively over the length of the link, you'll just have greater attenuation, and you may not know why that cable is performing poorly.
Yeah.
So when those fibers cross inside the cable, cross one another, and they're packed so tightly, that is um, a great recipe for creating those micro bends. And then, even beyond that, some of the other aspects that will affect your overall performance across those long spans is just your fiber attenuation. So operators are asking us to produce fibers that have lower and lower and lower attenuations because that makes huge dividends not only in the performance across the C and L bands. They can truly maximize the number of channels because if you lose any channels across that distance, it can cost a lot of money, and impact their bottom line. And then just the distances you have between amplifier sites and regeneration, you can start to expand these things a little further when you do reduce that attenuation.
Yeah, that's interesting. Yeah, I was going to actually get into what the service providers were sort of asking for now, and how that maybe has changed in the last couple of years. So we know the cloud providers are very interested in, um, you know, uh, connecting AI data centers, and kind of enabling them to carry low latency, high bandwidth paths, both inside the data center and outside the data center. I'm very curious if service provider, like the traditional cable and telco needs, have changed all that much since the 5G build out, or are they asking for things, different types of technical specifications these days?
Interestingly, because this is happening so rapidly, um, a lot of these routes are also getting subcontracted out
Mm,
through other service providers. So we've even seen tier three service providers partnering with a hyperscale to complete these routes.
okay.
Um, so one thing that, yeah, I probably didn't expect coming into this era is that those service providers would require the same level of training and understanding and rollout for these new cable designs and kind of help them understand what the needs are and why their customers are asking for such high performance, high density, and so forth. So yeah, it's definitely getting out there, but primarily all for the same application. I don't think telcos are are looking this for other use cases.
Yeah, that tracks with what we were seeing. I'm just curious too, from a manufacturing point of view, like how difficult is it? Because you have to have time to, you know, manufacture things at scale, like that video was showing, which we'll link to in this thing. It's like you kind of forget all the steps that are involved in uh, purifying the glass, testing the cable, the rigorous sort of scientific process you have to get the cable to work anyway, and then
Absolutely.
to be able to make it at scale. It just dawns on me that the technology world is so impatient, with building out capacity and stuff like that. How does that kind of weigh on a company like Prysmian to be able to um, both forecast what what you can do now to kind of in the current plant capacity, and then you know but you still got to talk to customers that want stuff that you haven't built yet. So how does that work?
I'm so glad you asked that, Phil, because my last 15 years I spent outside of manufacturing, selling cable.
Mhm.
But you have a renewed appreciation for a lot of the intricacies that go into making, especially fiber optic cable. Um, and as a manufacturer, you want your plant production line to be as steady as possible. And when we talk about how the industry has evolved over the past 2 decades, that line is much less flat. And I think a lot of manufacturers get caught up in the buzz of any of those new um, use cases and market conditions that may overspend or expand too much. So what is the appropriate level of expansion,
Yeah.
right? And that's hard to attain. But I think Prysmian does a really good job managing that and planning growth carefully as to not get caught up in all these market trends.
Yeah, it's got to be, I would say, remarkably difficult, especially because you're making something that it's not software. It has to be,
Yeah,
it has to go through such an exact process just to get out the door. So you can't overcommit, but at the same time, there's a massive build out going on, and there's actually money for it in some places. So
right.
so we have to kind of weigh the two things at the same time. Back, our audience, the folks that follow light reading and Informa publications generally, might have run into you or might have seen your discussion at Data Center World earlier this year, where you were talking about optical networking innovations that are supporting AI. Let's close with this. What's one of the biggest changes I think you've seen that you've seen in the either the fiber business or the fiber technology, that that's been brought on by this by the demand for AI?
Well, I could answer that question in so
Doesn't
many
have to be just
ways.
one.
Yeah. um, I would say our version of it is branded as flex ribbon,
Mhm.
but intermittently bonded ribbon, rollable ribbons, um, whatever you want to call it. There's many different brands in the industry. I would say that's probably the number one thing that has unlocked cable manufacturers' abilities to meet the high density needs,
Mm.
because you've kind of broken the handcuffs on cable construction as it used to be. You had so many limitations to get the fiber from point A to point B
Mhm.
that it could actually operate, properly. So yeah, being able to pack fibers densely into a package that's small enough to get into traditional enclosures and panels and things like that is probably the number one catalyst for where we are today.
Yeah, it's pretty interesting. Well, I will as we go on, we'll probably have as the year goes on, we'll probably have specific market things we can ask you about as things evolve. I mean, I know Prysmian is an acquisitive company. You've made a lot of changes over the past 5 years in terms of adding to capacity with M&A. So we might circle back and talk about that some other time. But
Yeah, I'm surprised you didn't mention channel.
yeah, 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 and channel as well. Yeah, that's a big
So
one. Well, yeah. I mean, we could address that now. I think I want to kind of leave it with the technology discussion for now. We'll get into the market uh, dynamics a bit later. But
yeah, that'd be great.
thanks for your time today, and thanks for being part of the Light Reading Podcast.
Yeah, thank you, Phil.